Alright guys, let's start. Let's see what we have. Okay, so it's a hard one, but let's try to do our best. If not, I'm deciding instead of we'll try to look at editorial first before heading out to ChatGPT, because I feel like that'll be more beneficial. Okay, let's read. We are given an array nums of length n and an array queries. GCD paired an array obtained by calculating a greatest common divisor, okay, of all possible pairs, and then sorting these values in ascending order, okay. For each query, you need to find element at index query I in the pairs, returning where answer I is the value at for each query. Okay, 1 second. Let's break this down. That's too much information. Okay, let me pull out Excalidraw. Okay, initially we're given an array. We're given 2, 3, and this is an array that's given, okay, of in length n and queries. Let's say we're given 0, 2, and 2. Okay, let me send to this. Let GCD pairs generate an array obtained by calculating. So we have to let's have a GCD array obtained by calculating all possible pairs from nums from I and j. Okay, so all possible pairs of nums. So we could have 2, 3, 2, 4, and then 3, 4, right? These are the only possible pairs, or do we consider 3 to a pair? And then sorting. So first we have to find the greatest common GCD in all of these, get each of the values, and then sort it. After sorting, let's for now assume we get 2, 3, and 4 or something, and another 2, 2, 2, 3, 4. Let's say this is what we get, and then sorting for each query I. So for each query I, you need to find element at index. So element at index this. We find the element, return the answer array where answer I is the value at. Okay, so we have to create. So for these queries, I need to find correct. Okay. So first, what do we have? What do we need to do? Step 1 is we need to find GCD between for all possible, that's the hardest part, right? All possible pairs in nums. Then step 2, we sort the GCD resulting array GCD. Okay, and step 3 is use queries as index and store the answer and return the array. That's like the overview of what we need to do. Now, to find a GCD between, so what we know is, let's say if we have 2, 5, and well, let's say 2 and 5. What is the greatest common? So GCD would be minimum value of the smallest value, comma, whatever 2 divided by 5 is, right? So 2 2s are 4. I GCD this modulus, right? Whatever the 5 divided by 2 answer is 1. So between 2 and 5, our greatest common divisor is 1, right? Let's consider another example. Let's say we have 2 and 6, or yeah. So here the what greatest common divisor would be the smallest value and the bigger modulus smaller, or is it the bigger value? So GCD would be greatest common denominator. Either it is minimum of greatest 2, 3, 6 divisor, right? Divisor means something with which our modulus is 0. Am I getting this wrong? More examples. Between 2 and 4, the greatest common divisor is 2, right? So how do we get this value between 2 and 4? We get it by minimum of 2 and 4 divided by 2, right? So let's consider another example where instead of 2 and 4 I have 3 and 6, which I know the greatest is 3. We get minimum of 3 and 6 divided by 3. So isn't that wrong then? Then we're getting 3 and 2. So it should be, so GCD between 2 ints is equal is the sum of what? Bigger comma bigger divided by smaller, right? Explain another example. We have 5 and 10. And is our nums sorted? Here given an integer array nums dot length, not given that nums is sorted, right? Nums could be 4, 4, 2, 1, yeah. Okay. try counting number of pairs that have a greatest common divisor of G. How will we count? Use inclusion and exclusion. I don't know what this means. Try counting the number of pairs. So here we given GCD pairs equal to GCD of nums0, nums1. Yeah. 2 and 3 answer is 1. 2 and 4 answer is 2. 3 and 4 answer is 1. So it will be 4 and 4 divided by 3. I think this is the correct way to. Okay, but let's then the thing is we could have 100,000 values. Okay, same amount of queries, and queries bracket I is less than n star and minus. So are we using, how do we get pairs? How to get all pairs, or do we need to get pairs? So from 1 to 10, if I have 1 to 10, what numbers, all prime numbers, will have the greatest common divisor as 1? Yeah, all the even numbers will have, oh, it's the smallest. So for example, there could be so many combinations. Okay, let's try to look at. Let n be the length of array nums and m be the maximum value in nums. Okay, a brute force would get and compute since n can be as large as this approach is clearly infeasible. The key observation is that although there are many pairs in the range of possible, every GCD, this set of pairs we enumerate all possible in count how many pairs. First count the occurrence of each value in nums and store them in an array. Found the occurrence because we can have multiple values, and then for every positive integer I enumerate all of its multiples to count how many elements in nums, and any pair formed from these elements have. Okay, so what's happening here is first count the occurrence. So we create like a frequency array, so and store them every count. Okay, and then for every possible integer I enumerate all of its multiples to count how many elements in nums are divisible by any pairs formed. But at least I is not the external in GCD. So to obtain the number of pairs of GCD, we traverse I from large to small and apply whose, then subtract the number of pairs of GCD, and so on. The remaining count is exactly the number of. Finally compute the prefix sum of these counts. Prefix sum at an index I represents the number of pairs. Perform binary search on the prefix sum array to find. Okay, so what's happening here is we have to return an integer array. We have a public function GCD values that takes in two arrays. One is integer and long. Okay, initialize m0, get the maximum value, then we create a count array and we set it to size of maximum plus 1 for each count. Okay, that is correct. I'm creating a frequency array for each value in num for integer I equals to 1. Are we given that I num doesn't have 0? Right, it should be given somewhere. 1 second. Yeah, it's given right here. The nums can't be 0. Okay, so create a maximum, and then what's happening here is we loop from the smallest I to the biggest value m, and then for each, and for integer j equals to I star 2, j must be less than equal to 1. So what's happening here is one loop is running through m is for num, okay, and j equals to I star 2, j plus equals to I. Count, I don't know what's happening here. Let's here key observation is although there are many pairs, the range of possible GCD values is small. Every GCD. Okay, up till this part I'm clear. First count the occurrence of each value in nums and store them in an array num. Then for each enumerate all of its multiples. Okay. To learn, not able to understand after this part. So let's suppose we have nums. Maximum value is 6. Step 1 count. We create a count array. So we have 2 1 times 3 1 times. Okay, because 2 appears once, 3 appears once, 4 appears. Why do instead of repeatedly scanning nums, we can instantly know how many of each number is this. Now comes the confusion. For every possible integer I, what does the sign even mean? I forgot. It really means for integer I in range in I and m. So if m is equal to 6, we will process 1, 2, 3, 4, 5, 6. Notice these are the possible and not the elements of the array. Yes. Look at the multiples of, suppose I equals to 2. Which numbers can have GCD divisible by 2? Only multiples of those are 2, 4, 6. So we compute divisible equals to count equals to 2, which is, so there are 3 numbers. Now imagine choosing any 2. Pairs are 2 and 4. 2 and 7. Those pair has greatest common. Notice I didn't exactly, however, happen to be exactly 2. Okay. Now what? Look at multiples of I. When I is 2, only have 1, 2 value, right? Which numbers can have a GCD divisible by 2? Only multiples of 2. So we compute, which is okay. So now imagine choosing any 2 of these numbers are 3. Okay. Notice I didn't say exactly 2. For example, here all happened. Now try multiples of 1 or 6. So using count, there are 4 numbers, number of pairs. Now try I equals to 3. So for every possible GCD candidate I, this counts how many numbers are. Then pairs, the numbers. Computing with pairs and no. So when look at multiples of 2. Okay, let's try to look at the code again and try to see. Okay, so we have the max value, we have the resulting array, we create frequency array, and for I and m, I plus plus. For j equals to I star 2, j must be less than equal to m, j must be less than equal to m, and j plus equals to I. How does this make sense? For I equals to 1, I must be less than equal to m. Okay. How which numbers can have? So just to clear, when we have a number, let's say 2 as a GCD, and we need to find the numbers that are divisible, how are we going to get? Let us count arrays. Okay, now suppose you're checking for every how many numbers. Instead of checking every number, we loop through multiples of 2. So multiples of 2 would be, we see j plus equals to I. Got it. I equals, this is what it means. So when we do, but why do we initialize j I star? Okay, why do we start at 2 or 2I? Suppose we're checking, we want count. Okay, understood that part in Discord by accident. Okay, so when we start at the very first, we want j to start at the next possible equals to 1. J must be count of I plus equals to count of count bracket I, for I must be less than 2. I understood this part now. So we loop plus equals to I, like every multiple of I, and we add, we keep adding. Okay, and then for I count I equals to, see what this is, because it also includes power. Okay, that much that I got. Now what happens next? Let's continue the same example. Okay, step count the number divisible by each I for number of pairs. Okay, this is why we process from start with I equals to 6. Okay, are we starting from the maximum value? Understand this part, understand this. First you count, so what happens here is we have a number maximum value is 6. Stage 1 count stores the frequency. Okay, how many times does each value support? Stage 2 for I equals to 0. Notice something, it starts at add count, which is 3. This means 3 numbers are divisible by 2. Those numbers are 4 and 6. Just n equal to 3. How does overfitting happen? Let us use a simple, these pairs are 2, 2 and 4. Now let's, these are pairs where both numbers. Oh, I see, yes. Alright, so what should happen? So pair 4, 2 belongs only to. Another example, every pair. Okay, and this is that part. So far what happened, what I've understood is, first let's create an integer m which is 0. We find the maximum, then we create a count array empty, then we create a frequency of each integer in the count, create a new array for that, sorry, assign where is like right, it's a long, okay, and then we loop from I equals to 1 to all the values or to the maximum value, and then we have to find for all multiples of I, count of I would be how many times that thing is. So for if I is 2, count bracket I is 2, 2 is the greatest common denominator of all the even numbers, not the greatest, but it is a common denominator. So for each value we add it to its count, okay, and then for I equals to 1, I must be okay. So teacher answer equals to new teacher plus query long q equals to query bracket k plus 1. Why is queries is teacher array answer. We create a new array and then we loop through k is less than queries dot length. Okay, what's happening here? 1 second. Let's try to not look and see what have we learned so far. So first we create integer m, right? We find the max value, find the max integer m, assign it the value 0. So for integer num in nums, right, for each value we do m equals to math dot max of what, of m comma num, right? This way we will get the maximum value, and then we create do I create an integer array or long? Then we create a frequency array, integer array count equals to new integer array of whatever the maximum value is plus 1 size, right? And then how do we create a frequency array? We go through each value in nums. For teacher num in nums, right, we do count bracket num plus plus, right? This will create us a frequency of all the values. So now when we have how many times 2 came, 3 or 4 came, so we loop. Now we loop till max value, right? Now what do we have to do? We have to find the greatest GCD of all the, how many pairs could have that GCD, right? Let's see, is this correct so far? Create m0, we find the maximum, we created a new frequency array. Yeah, it should have been long, because new long of m plus 1, and then for integer num and nums we create a frequency array, okay, and then we loop till the max value, and then after we loop to the max value we find the, so okay, after we loop for, we have to loop till the max value for integer I is to 1 and I must be less than equal to m I plus plus, okay, that is fine. Now what do we have to do? We loop for integer j equals to 2 star I think. I'm not looking at the screen as of now. 2 star I, and j must be less than equal to mj plus I, right? Because we have to move it plus equals to I, sorry. Or j is I 2 star I, j must be, and then what do we get? We have to create a count bracket I plus equals to count bracket j. So how many of those have? So now we have to remove the duplicates. So right now what we have done is, if we have an array of 2, 3, 5, and then so we go through 1, 2, 3, 4, 5. Those are 5 integers in our count array, right? Because 5 is the maximum value, and then we created a frequency for integer j equals to, for I equals to 1, I must be less than equal to 5. J is 2 star I 2, and then if it is 0, count plus I will be 0. Okay, what if 2, 4 and 6? So we count 2 and 4 and 2 and 6 3 times, right? So 2 itself, so 2 and 4, 2 and 6 we count 2 times. So initially count is 1, right? And then help me understand the removal of duplicates in count. So far my understanding is, initially we add the value, we add the frequency to each possible value, then we loop to add frequency to its frequency by adding its multiples, and then so once we have added to our multiples, right, so this is where we are adding it to our multiples again. So we are not adding to, I think 45 minutes are over, but I'll still try to finish this off. Only thing to fix is what count means after each loop. We are not adding frequency, we are changing. Okay, let's walk us through. Okay, let's see. So initially I have one count because 2 is 1, 4 is 1, and 8 is 1. Means add frequency. So count, let's see what happens for I equals to 2. Initially count 2 is 1, the number 2 itself. Now add frequencies of the multiple. Count bracket 6, we don't have anything, it's 6, so it will add 6 and 8. Now count 2 no longer, it means there are 3 numbers. Okay, count. Okay, so the meaning of count changed. Converted into pairs equals to 2, which is means there are 3 numbers. Now how many pairs can they form? 3 numbers can form, that's 3 pairs. So number of pairs, oh okay, I see. So that's how many pairs can they form? They can form, that's 3, so still happens to be 3, but its meaning has changed. Okay, now it means 3 pairs. Notice we didn't add anything here, we just simply replace the number of elements with number of pairs using the count. Now removing, now we have count of 2. Okay, so I understood this part. We count the number of pairs. Now removing, now we have count of 2 is 3, count of 4 is, sorry, count of 4 is 1, and count of there these pairs included where the pair 4 it has, so it should belong to. So to fix that, count of 2 becomes, represents minus. Okay, so what's happening next is, so here we got the number of elements, now number of pairs, right? How do we get the number of pairs? So we loop for integer I equals to 1 must be less than equal to m and I plus plus. So what do I have to do? Count, right, bracket I equals to number of, how do you find number of pairs is n star n minus 1 equals to count bracket I star count bracket I minus 1 2, right? And then once we have the number of pairs, we remove duplicates by traversing backward, right? So we go from 4 integer m equal for integer I equals to m, I must be greater than equal to 1, right? Because I am minus minus, right? So what do? We do count bracket I, so that is the maximum value right now. For I equals to m, I must be greater than, if I is the maximum value for I equals to m, I must be greater than equal to 1. Okay, and then the other thing should be for equals to, why is j, if I do j equals to I star 2, doesn't that mean m is the maximum value? If m was 5, j becomes 10, j must be less than equal to m, so that won't happen. Okay, so this condition will stop it if j goes beyond m, and then we do j plus equals to I, right? So what will happen is, it will up until m is 8, right? For let's say m was 1, 3 I must be greater than equal to 3. It will run 3 times, the inner loop will run 6, and x is not greater than equal to 3, so it will j plus equals to I don't understand this loop, but what do we do here? We do count bracket I minus equals to count bracket j, coding while trying to figure it out. Doesn't the last loop check out of bounds since we keep doing j plus? So inner loop, suppose m was 10, so for m was 10 and I is 3, 6, but doesn't I start at m? First iteration I is 10, iteration loop runs equals to count of 10, false loop ends. Okay, so what do? Once we remove the duplicates by tracking backwards. Okay, so once this is done, okay, why do we have, so what does this loop do? So we loop again, and now so let's continue pairs. Yeah, remove our counting. So before this, all pairs 3, so So I remove the left, for example, for I equals to 2 to this. Okay, now count. Now this changes the meaning, and before prefix sum index meaning number of pairs with prefix sum does what? Let's find what happens. So after removing the duplicates, count means number of pairs. Okay, for example, 2 pairs meaning 2 pairs are 3 pairs. Okay, the problem with this, imagine a query asks what is the fifth element. To answer this we need to know how many elements is the answer. Okay, changes before. Okay, so what happens is we do the prefix sum now. So now we do prefix sum to get many pairs. So we do for I equals to 1, I must be less than equal to m, right? And I plus plus we count bracket I plus equals to count bracket I minus 1. This creates a prefix sum, and then we create an integer array answer equals to integer array of size queries dot png length. And then what do? We loop for teacher k equals to 0, k must be less than queries dot length and k plus plus, right? So for each, so we create a long queue equals to queries. Okay, y equals to queries plus 1. Oh, okay, because k equals to bracket k plus 1. So queries bracket k is the index number, right? How do you define reserve? Left equals to 1, right equals to the last. We just do this and this. Left and right equals to 1 and m. Then we do while our left pointer is less than the right pointer, while they don't overlap. Teacher mid equals to left plus right. We haven't protected it by 2. Why don't we do no flow? No, I meant in binary search. Okay, so it should be left minus right, left plus right minus left. This is just so our integer doesn't overflow. If count bracket, if the middle value is greater than equal to q, then we move our right to the mid, else left equals to mid plus 1, left equals to mid plus 1, and here answer bracket k equals to left, and then we return the answer. Okay, alright guys, this is it for today. Even though we tried to learn a little bit, I don't think I got everything in, but definitely got some kind of learned something at least. Alright guys, I'll see you next. I think I'm gonna work on, I have to go out for a bit and then I'll probably start reading Java.